let's move on to our section 2. Carissa explains it all.
Yes. And again, if you have a better name for this, please, by all means.
Oh, I like the name.
You like the name.
We even have we have a thing. We have a thumbnail we put up.
Do we now?
Oh yeah, we've had one since like the second one. It's blue. It's nice. Greg did it.
Okay.
So so let's move. So let's do section 2. So this is high pass and low pass filters.
Yes.
So, just so everybody knows, a high pass filter lets frequencies higher than a certain point through. Oh.
How about I actually cover it?
Okay.
In the thing, because I thought you looked at it and I thought you realized that I covered it in the presentation.
Fair enough. Would you like me to change the slide?
Yes, please.
So we're streaming this to Instagram. I'm not sure. I've got the front facing camera is kind of awful. The rear camera on the iPhone is very nice, so I can't see if anybody's watching. But if you're watching from Instagram, be sure that you're subscribing. On YouTube, it's Get Off My Lawn Records. And but let's go on to the next slide here. Let's take a look. So high pass filter.
High pass filters.
With a typo. Look at that.
What are you talking about?
You forgot to capitalize the A in an.
Hey, you know what, proofreader? If you noticed that the first time, you should have corrected it.
I should have. I just glanced at these. All right.
Yeah, uh-huh.
So what's a high pass filter?
A high-pass filter is an electronic filter that passes signals with a frequency higher than a specific cutoff frequency and attenuates signals with frequencies lower than the cutoff frequency.
Attenuates a little. It doesn't let them through at all.
It kind of depends on the filter, but yeah, for the most part, the whole point is to not let it through.
Right, so if your cutoff is 200 hertz, everything over 200 is going to get through, but everything under 200 is going to be cut off.
Right.
And then, like, 180 will get through, but it'll be quiet. That's where the attenuation comes from.
Yeah, it's a curve more than, like, a straight drop-off for the most part.
Right. And this is for all of the synth guys, because a lot of my friends from synth memes, shout out to the synth memes guys. This is really for them. So, so it depends on the filter design as to what the curve looks like and how much it rolls.
Right.
Off. Okay.
Right.
So this is a passive filter you're showing?
Right.
First order? Yeah, okay. Which I think is either a 6 or 12 decibel first order. 12 decibel per octave, I think.
Yeah, everything I've found has said that it kind of depends on like the materials used and whatnot. So it's
true. The kind of capacitors and resistors you use will have an impact.
Yeah.
So on the schematic here on the screen, you have that's the positive on the V, right? So it comes through, hits a capacitor, and then you're bridging the negative side with a resistor. Actually, I think that's backwards.
Yeah, it's backwards. Voltage in is the negative side.
Yeah, okay. So that's the negative, and then the lower line is your positive signal. And so you're letting some of the positive pass over to the negative side. That's what creates that high pass. Cool. Yeah. All right, let's go on to the next slide.
All right.
And then, that looks like an active filter, because that's an amplifier there, that triangle in the schematic, right?
Yes.
Yeah.
That is an operational amplifier attached to a ground.
Yep.
So, yeah.
Yeah, these are rumble filters. That's where they're really handy. But also, with high-pass filters, they're cutoffs.
They're cutoffs.
Or they're sorry, it's midnight and I'm tired. For speakers.
Yeah, that's what it says there.
Yeah. Where does the word speaker? To a tweeter. The tweeter's the little tiny guy on a speaker.
The one that handles the higher frequencies.
Right. And the woofer is the one that handles the low.
Right.
So that's what we're seeing here. It does the same thing. It comes across the negative. You do the resistor, just like we saw, and then you get a positive is hitting an amplifier or is going to the ground. Got it.
Right.
Cool. Let's move
Okay.
on. So a low-pass filter. Oh, look at that. You throw a resistor on the line, and that's it. Yep. And the capacitor's creating your resonance, I believe.
The capacitor is taking the higher frequencies, is what it's taking.
That's not true. It's not true, because if you put a big resistor on a line, it low passes. Like if you take a resistor and you put it on a speaker line, it'll just low pass. The capacitor's doing something. I'm just not sure what it's doing there.
Basically the faster frequencies are
they're going to get cut off by the resistor.
Yeah, they're going to the capacitor is what they're going to, and then which is just going to a ground. Whereas the lower ones aren't making it to the capacitor, and that's how they're coming through.
The lower ones make it all the way through to the capacitor.
No. The lower ones come out.
Gotcha. Okay. You know, I built one of these in college. You can build them with Radio Shack parts.
Sure.
Yeah.
You can build just about anything with Radio Shack parts. That's the brilliance of Radio Shack parts.
Yep. Don't talk right into the microphone. So...
And here, I thought you wanted me to talk right into the microphone.
I just want you to speak up. All right, so applications of low-pass filters. Subwoofer crossover, sure. Radio transmitter, yeah, all right. Guitar tone knob is definitely a low-pass filter, yep.
Mm-hmm. And the one I never knew was the radio receivers and television sets, because those are lower frequencies. Those are larger wavelengths.
They are.
So
They are.
I found that rather fascinating.
Yeah, so the schematics here, that's what they're doing.
Yep.
All right. So that's how a high pass and low pass filter work, at least on an electronic level, right?
Mm-hmm.
It should be noted that your filter cutoff is a potentiometer that applies a change in resistance. And that's how you set your cutoff frequency, is the amount of resistance you put on there. The capacitance values...
At least in musical applications.
Yeah. Well, in general. It's just how you... Okay. So yeah. So that's how that goes. If there's anything you want explained on Carissa Explains It All, let us know in the comments.
Yes.
And share this with a friend. That's the most... Helping other people find out about what we're up to is really... the most helpful thing you can do to support what we're doing if you can't buy the records. Not everybody's got $10.
Right.